Let's see what happens when we find the product of a rational number and an irrational number. The square root of 5 times 2 is equal to 2 root 5, an irrational quantity. So can we conclude that the product of a rational number and an irrational number is always irrational? Let's assume the opposite, that a rational number which we express as a fraction a over b multiplied by an irrational number x gives a rational answer, which we represent as m over n. We manipulate this equation by multiplying b over a on both sides and get x equals m over n times b over a, which gives us the fraction mb over na on the right-hand side. But we have now formed a fraction that has an expression that will be an integer in the numerator and an expression that will be an integer in the denominator. This means that x cannot be an irrational number after all, and we've contradicted our original assumptions. So we can conclude that the product of a rational number and an irrational number is always irrational, and we've used a proof by contradiction to show this result. Note that we could work in exactly the same way to prove that the quotient of a rational number and an irrational number is also always irrational.